So tonight, I would do the homework that's in the module for this section. Then, if you have nothing else to do, then try to start the quiz. But you can wait on those quizzes. Like I said, you'll have Wednesday to work on them because it's a work day. So you just have Wednesday to work on that. But do the homework tonight. Do the homework tonight. All right, we're going to talk today about continuity. We've already done this. Hold on. Moving this over. There, to be a function that is continuous. Look at this, writing notes again. I know, at a point if. A function is continuous at a point if the following three conditions are true. We did this last year. We did this last semester. We did this last year, though. There have to be 3 points that are true. F of A has to be defined, meaning they're going to give you a point. Is the function continuous at 3? How do I know it's defined? Plug in 3. If you get out an answer, you're defined. If you don't get out an answer, you're not defined. Okay? How would I not get out an answer? Well, you would have a square root of negative number or something like that. That doesn't exist, okay? Step number 2, you have to check the limit on both sides. The limit of, as x approaches a, of the function has to exist. That's why we did all the work on limits. And then this is the third step. Whatever you get as your y values in step number 2 has to be the same as your y value in step number 1. And the way they write that is like this. The limit as x approaches a of the function from step 2 has to equal the same as if you plugged it in. These are the 3 points of a function to be continuous, and we're going to work through some of these problems in a minute. Something that you do need to realize, though, and put this in your notes, any polynomial, a polynomial like x cubed plus 5x squared minus 2x, okay? And rational function. What's a rational function? Anybody know what a rational function? Rationals are fractions, ratios, okay? They are continuous along their domain. They are continuous along their domain. What the heck does that mean? Well, polynomials, quadratic, what's the domain of any quadratic right now? What's the domain? All reals, negative infinity, okay? What about x cubed? Negative infinity. There's no holes there. There's no gaps. So how are you not continuous? You have holes. You have asymptotes. You have jumps. That's how you are not continuous, okay? So this is what you want to write down. If there's a problem at a hole, at an asymptote, at a jump, something like that. Piecewise functions, we got problems, okay? Rational functions, we got problems in the denominator, okay? Problems occur, occur at holes, at asymptotes, at jumps. We don't like those things, okay? And that's where our domain is going to change. But we're still continuous along our domain. If our domain says negative infinity, we're good. So I'm going to show you a few examples of what it'll be like on homework tonight. Okay, so they're going to give you a bunch of functions and they're going to say, where is it continuous? Where? Tell me in interval notation, because that's what we like. Where is it continuous? So state the intervals where the function is continuous. Oop. Number 1. F of x equals x squared minus 2x plus 3. Let's write a couple of them. Minus x. 1 over x. Let's write them all. Ain't nobody got time for that. Now, am I going to do all the problems that you'll have tonight? No, you're going to think tonight. You're going to have to actually use some algebra skills. I'm going to stop at 6 right there. Yeah, not really. You can write the answer right here on the side. This will be like the first few part of homework tonight. Tell me where it's continuous. Just tell me where it's continuous. Where is it nice?
So we can just graph these.
You can graph these, yes. Most of these you should know what they look like, though. I mean, honestly. If you don't know what number 1 looks like, we are in trouble. Yeah. All right, so if you're still writing, that's fine. Could you do number 1? Could you tell me where it's continuous at right now? Negative infinity to infinity. Its domain is negative infinity to infinity. You are continuous if you're a polynomial along your domain. And that's what this was a beautiful parabola. So guess where it's continuous from? Negative infinity to infinity. You don't have to write C-O-N-T, but it's just negative infinity to infinity. That's where it's continuous. What about x cubed minus x? You know what that one's going to look like? It's a polynomial function. Yeah. Same thing. It's a polynomials are continuous along their domain. This end behavior goes down, up, has a little, thing in the middle. It's good. All right, but then we got this rational function going on. Do we ever have a problem there? Where's that problem at right now? 0. There's an asymptote at 0. If you have an asymptote, you are not continuous there, but everywhere else you are. So what would you write for me? You'd say, well, I'm continuous from negative infinity up to 0, united with, where's the other half? Done. Yes, if you don't know what this looks like, you can obviously put this in a Desmos or a calculator just to look at it, but you should know. All right, what do we want to do here that we know we should do because we see x? Yeah, we should do a little x minus 1, x plus 1. What cancels? What crosses off? Oh, we have a whole because we cross from top to bottom at x equals 1. That means we're still not continuous. Well, are we still continuous up here? Yeah, we're just not continuous at the whole. We're continuous everywhere else, but we're not continuous at the whole. So we'd say, okay, we're continuous from negative infinity up to that whole, 1, and then 1 to infinity. We just can't include 1 because there's a hole there. Asymptotes and holes. All right. What about that one right there?
There's a asymptote. No, wait, that's I. So
Do we graph i's?
No, negative infinity.
Is there ever a problem in this denominator for x?
Oh, it can't.
Would there ever be a 0 for the denominator? Because you can't, that's what we have with fractions. That's where our problems with fractions. We can't have 0 in the denominator.
No.
No, there's no, I could plug in negative 1 and still have an answer on the bottom. Pay attention. I could plug in a fraction. I could plug in a square root. I'd be fine. This is actually, and you can look this up on, Desmos, put it in your calculator. This is continuous the entire time. You could draw that and it looks pretty. Okay? All right, last one. I kind of flipped it. We know we have to factor.
1 over x.
We know things cancel. But the thing that doesn't cancel is called a what in the bottom?
Denominator.
It is the denominator.
Horizontal asymptote.
There's a hole at this one, right?
Vertical.
What's that right there?
Negative.
-2, and that is a hole. But there is a asymptote,
Banger. Vertical.
a vertical asymptote.
That's it.
Asymptote at what value? 2. Okay, so we have 2 problems here. We have -2 as a problem and 2 as a problem. So how do I write this correctly? Where is it continuous then? From where to where? Negative infinity to 2, -2, then where?
Negative 2
-2 to 2, then where?
to infinity.
Beautiful. That's your continuity right there.
Let's go, guys.
So the first part of, like I said, homework tonight is going to be like this. They're going to give you functions. If you don't know what it looks like and you're like, I don't remember, go ahead and use your calculator. I'm not here for you to graph it. I'm not testing you on that. And tell me where it doesn't have a hole, where it doesn't have an asymptote. Well,
So which of those laws is broken first?
which of the laws is broken first? For which one?
For that one?
Well, we're not there yet because we haven't defined it at a point. So the point is, the hole is the point. If I had defined it at that point, we're going to break a law. We're going to do that in a minute. All right. Which will let us into that so nicely. So I need you to write this down, discontinuities. So they can ask things differently. Why am I spelling this wrong? There we go. Discontinuities. Wow, there's a lot of I's. Okay? You need to know the following. No longer are we going to call it whole in calculus. We're now going to call it a removable discontinuity. That's what we're going to call it. Yay! Why? I don't know. Okay. And no longer shall we call it asymptote. No, we shall now rename it to non-removable.
What?
Why? I don't got me. I'm just here to teach you it. I don't know why. Now they just this is now the type of language they're going to use. They're going to get state the removable discontinuity. Just know when you see removable, it means whole. State the non-removable discontinuity. There must be an asymptote there. Let's find it. Okay? That's what they're saying. Okay? So know this, and I'll show you an example on the other side. Okay? State the type of discontinuity. So we already know there's a discontinuity somewhere going on. They're going to give you a function. 2x squared minus 5x. I'm bringing this back because I can't believe how many people still don't know how to factor this. Okay, I'm already sure that one of these factors is going to be an x minus 4. I don't know if you realize that, but the math is kind of like obvious like that. You know, it just does it. But if you don't remember how to factor, you say what two numbers multiply to negative 24 and add to a negative 5. Anybody know? You should. Negative 8 and 3. So when you factor this, you write x minus 8, x plus 3. You're like, wait a second, I don't see it. But there's a 2 in front. You have to divide by 2. Remember doing that? Okay. And now, will things cancel? This is now x minus 4. This slides up and becomes 2x plus 3. These will cancel. You are now left with the function 1 over 2x plus 3, by the way. But if I cancel, I must have been a what? Whole, which we're now going to now change to removable. There is a removable discontinuity, again, aka whole, at, and then you just write at x equals what? 4. Don't say negative 4, say 4. But then if something is still on the bottom, that is a asymptote, also known as a non-removable. You need to know the difference of these words. And then you say at x equals what? Set that equal to 0. Negative 3 over 2. Okay, you have to do that tonight, part of your homework. And part of the quiz. Example 2. And this goes to, Will, what you were talking about. Which continuity rule is violated? These are the words they use in the quiz. In the picture. So here's a point A. Here's a graph, and then here's a graph, and then I'm going to draw another picture here. Here's the point A. Give you a minute to draw that. Which part of the continuity rules, those 3 rules again, is violated in the picture? And I'm going to explain them again so you can understand. Okay? Number 1 says you have to be defined at A, meaning, listen, you have to have a closed dot at A. Do you have a closed dot anywhere at A?
Yes.
I do. I've passed test 1. Remember we did this like a couple years ago, we had to pass test 1. Okay? Hey, by the way, does this one have a dot closed at A? So both of these are not violating rule 1. There is a closed dot at A. Okay? Rule 2 says that the limit as you approach A from both sides is also defined. It exists. Okay? Well, let's check the limit. If I was going this way, wouldn't that y value be different than this y value? So does the limit exist there? So number 2 is violated. Number 2 is violated, which is the limit as x approaches A of f of x does not exist. Okay, so however they answer it, but that's the violation. All right, so this one we already determined past 1. Does this one limits from both sides? It's the same one, right? So then it must be then 3. Why is 3 violated? Because they don't equal each other. Because this right here, let's say this was 3. I'm just making up numbers. And let's say this was 2. The limit here is 2, but the value is 3. They have to be the same in order to be continuous. So this is number 3 is violated, which is the limit as x approaches a of f of x does not equal f of a. Okay, this is important. You'll have a couple of questions and quizzes on that. All right, almost done. I only got just a few words for you. We're doing great. That was a very high-pitched word. Fine.
Is this the last one? No. This the last one that's guessing no?
Not the last one.
Wait, yes or no?
No,
You just said no.
we got lots.
Nancy got the homework.
We can't wait. Homework and quiz. That's what I'm doing. Both of them.
So, the homework's a lot of crafts. Do you expect work? It's just what this one says, like, where's the function continuous?
Nope.
Okay, so-
No, there's a lot of non-work for this one. Okay.
On the test, can we use Desmos?
I haven't decided that one yet. I'm thinking about it. I got to remember what I did last year. I know.
No, the calculator did something wrong on the homework.
You can zoom 6 though and go to standard view. So we'll see.
I needed a smaller decimal and I wasn't going. How about we flip the table?
We use Desmos the rest of
The problem is, if you're going to be engineering calculus, you need to understand they will take that calculator away so fast. Oh, it might be. You never know what the Lord has in store for you.
I'm going to sports.
Okay. Shh. Where is this function? Shh. Where is this function and this function continuous? So these are 2 problems in one. Again, you should remember from your pre-calc days what this looks like. This is a square root function, except it's negative x plus 3. So it's going to go this way. So it shifted to this way and went that way. So yes, you would put this in your calculator. Could you tell me where this is continuous? You would say from where up to where?
Negative infinity to 3.
Negative infinity up to 3. Here's the only difference. You ready? Can I be 3?
No. Yes.
I can. I'm allowed to take the square root of a 0.
Wow.
This is called one-sided continuities. So that's why I need to show you, yes, brackets and parentheses are going to become important in this. So you got to be careful. This is a bracket. All right? This one, if you don't remember what this one looks like, this is actually a semicircle because it fits the form of x squared minus y squared underneath the square root. And it would be of a radius 3 and negative 3. How do I know that? It's the 9. And it goes up to 3, by the way. So where is this continuous? From where to where? Bracket negative 3, bracket 3. You're going to have questions like that. You need to know that semicircles are allowed to be closed. Square roots have 1/2. Okay? I know. Don't worry. We only have 3 more. Stop crying. Oh my gosh.
No, my folder's in between.
No.
What is the homework? So the homework is just the thing on Pearson.
Not on Pearson.
The thing on camera. No.
No, on my open math.
That's on Bob. Wait, what?
No, there's a picture on campus.
Oh, the picture. Yes, that one.
Like I asked my
Oh, we only have 2 more left. That's fine.
What
But
do you know?
not really 2,
Don't
3.
confuse me. It's not on my open math.
It's in modules. Quiz.
It's on module. Oh my
There's
god.
there's a quiz on my
You literally just said my open.
I'll just wait.
I'm sorry. I'm trying to.
Yeah, I'll explain in a minute. All right. This is a piecewise function, and I will explain how to find continuity of a piecewise function. This is on the test and going to be on a quiz, I believe, also, okay? Is this piecewise function continuous at x equals 3? When they ask for continuous of a piecewise function, you have to check, again, all 3 parts of the continuity. So how do I check all 3 parts? Let me show you how to do it. It's actually not that hard. Number 1 says, is f of a defined? Or in this case, f of what? F of what? What am I looking for? F of 3. Is f of 3 defined here? What would you do? You should know how to do this. How do I find f of 3? Which one? The top one. Why? Because it's equal to. So plug 3 into the top and the top only. I can't tell you how many people get this wrong. What is the answer if you plugged in right now? -5. Why don't I square that? Because it's not in parentheses. Oh, my brilliant children, you are my brilliant children, okay? Negative 3 squared, just the 3 is being squared plus 4, so that's negative 9 plus 4, which is negative 5. Write that down if you don't remember. All right, so did we just pass test 1? Yes, we did. We passed test 1, okay? Pass. All right, test 2 says, check the limit from both sides. So I'm going to write this a little bit differently. I'm going to check the limit as x approaches 3 from the left of the function, and this is always what you do for piecewise. And I have to check the limit from the right of the function. Well, what does that mean in a piecewise? Well, which one of these pieces would be left, less, and which one of these pieces would be right? Top would be left. And didn't we already get an answer for the top when we plugged in 3? We got what? Negative 5. Well, what if we plugged 3 now into the right side, which is the bottom? I get what?
4.
Are those the same? Did I just pass test 2? So it is not continuous at x equals 3. You have to show, this is called justifying your work. You can't just be like, yeah, it's not continuous, so I saw it. I saw it in the graph. No, you have to actually show the steps. All right? Last question and we're done. But there's 2 parts to it, so just hold down tight. I'm going to write them both out so you can be done. You're so used to getting done so quickly and early last semester that you have forgotten what it's like to actually do work. Yeah. I love taking notes. Find the values of a and b to make each function continuous. I'm going to tell you right now, this is on the test for sure. And can't remember if it's on the quiz. I think it is. Greater than 0. Oh, they switched it on this one. Oh, wait for this one. You're going to love it.
Oh my gosh, you need
Can't you
I'll give you a minute to write it down. No, you can't graph. How are you going to graph A?
No, we can graph it.
Slide
no,
it.
you can't.
You could plug in some values if you want to. Let Desmos plug in some values, but. Okay. This is really important. Again, these 2 questions are notoriously done in Calculus 1 if you're going to engineering calculus. All the time. Okay, when I taught the 271 class, like, it was always on every single quiz and every single test, and you're going to have it on the test. I already told you that. You have to find the values for A and B that will make the function continue. You have to now, using your knowledge of the continuity rules, 1, 2, and 3, is it defined at A? Does it limit the same way? That's what we're going to do right now together, all right? Give you a little less than 1 minute to finish writing this, and we'll talk about it. Yeah, they love it on Piecewise. It always works on Piecewise. Okay, so first question. Right now, when I'm looking at piecewise functions, they're already giving me a clue as to what could be the problem x. Where do you think the x has a problem at? What value? Probably 0. Wouldn't you agree?
That'd be a pretty good guess.
I'd probably be like, there's probably either a jump there or a hole there, maybe. So what do I do with that knowledge? Well, I can't just plug in 0 right now because I don't know what A is. That's what I'm trying to figure out. But what I could go to then is step 2 of the limit part of the definition for a continuity. And again, what does it say? If you go back over here, it says you need to be able to have the limit on both sides existing. Okay? So watch how I write this. The limit as I approach, again, we think it might be 0 might be our issue. 0 from the left of this function has to be the same as the limit as I approach 0 from the right of the function. Do you agree? Isn't that what the rule says? All right, so what we just did before, you're going to do again. Plug 0 into the left. Which one is the left, top or bottom? Bottom this time. Plug 0 in. You would plug it in for x. You would get 0 squared plus a, or just a, wouldn't you? Okay. Other side, plug 0 now into the right. What would you get out for if you plug 0 in? 2 times 0 minus 1. Hey, guess what you just found? You just found the A that would make it continuous. You just found the A that would make it continuous. It would be continuous if A is -1. It would not be continuous if A was 2. It would not be continuous if A was 3. Okay? Can we apply that same idea to this one? Yes. But this one is going to be a little bit tricky. It's very neat though. It's very intriguing. Because we don't just have an area at 1x, we have 2 problem areas. What are my 2 problem areas here?
-1, 3.
That, right? Okay, but we're going to do the same thing we did for -1, but we're going to do it again for 3. So I'm almost going to put like a division here. I'm going to find the limit as x approaches. I'm going to start with -1 on the left. And then I'm going to find the limit as x approaches -1 on the right. And all you have to do is plug it in. That's all you have to do. Plug it in. Plug it in for what? Plug it in for x. But you have to be able to read the piecewise correctly. So plug -1 into the left of -1. Wouldn't that be, what would be your answer no matter what? 2. Plug -1 on the right. Wouldn't it be this middle section? Plug -1 in for x. What is this expression?
A plus B.
Negative A
Plus B.
plus B. Leave it alone. Leave it alone, because it didn't help me out. But watch what will happen over here. Now we're going to do it again for 3. The limit as x approaches 3 on the left of the function. The limit as x approaches 3 on the right of the function. What would be the left? If I plug it in, it would be this in the middle again, right? Plug 3 in for x. What expression would you get? 3a plus b. What would be the expression on the right of 3? Okay, now you're like, that didn't help me at all, Mrs. Seta. I don't see how to. Yes, you do. What could you do with these two simultaneously? 3a, how about I write it like this? Equals -2, negative a plus b equals positive.
Oh, not a matrix.
It's a system. You could do matrices if you want to. This is a system. But you can easily add these up and down right now and get rid of the b's, probably, right? Multiply by -1, so this will change. Oh, let me change pen so you can see. I'm going to change this, change this, change this. I get 4a equals to -4. What's a equal? -1, yes? And then what's b going to be? We'll just plug it back in and find b. Tell me what my b is going to be. What's it going to be? Plug it into this one or this one, I don't care. 1. 1. So you just found the 2 points A and B that would make this function now continuous. A has to be -1, B has to be 1, okay? This, now what are you going to do for homework? Because that's Chase's next question.
No.
He doesn't understand what you're talking
You're
about.
done the one before this one.
The one before this one?
Yeah.
The same.